Welcome back, student. Again, in this video we are discussing the reduction formula for integration of cos raised to nx into dx. Okay, and this is also very easy one, as you know the procedure already. That what is reduction formula? Reduction formula is the recurrence relation which can able to express the higher degree values in terms of lower degree. Okay, fine. Now let us go step by step, and it is very easy one. Okay, let us start with in. In is equal to integration of cos raised to nx into dx. I am going to express cos raised to nx as cos raised to n minus 1 into x into cos x into dx. As usual, we know that we are using the integration of product formula, that is called integration by parts. We people already aware of integration by parts. Integration by parts is integration of uv. Okay, so which is first function integration of second function minus integration of second function into differentiation of first function. Fine. So this is equal to first function is cos raised to n minus 1x. Integration of cos x is sin x. Okay, minus integration of v is sin x. Differentiation of cos raised to n minus 1 into x is n minus 1 into cos raised to n minus 2 into x. Again, differentiation of cos x is minus sin x into dx. I am applying chain rule here. So which is equal to cos raised to n minus 1x into sin x. This minus becomes plus, and take this n minus 1 outside. First you can write cos raised to n minus 2x. Again, sin x into sin x is sin square x. Okay, you can write sin square x into dx. In the next step, this is cos raised to n minus 1x into sin x plus n minus 1 times of, you can use the first identity, this cos raised to n minus 2x as it is. Sin square x can be written as 1 minus cos square x into dx, which is cos raised to n minus 1x into sin x plus n minus 1 times, you can multiply integration of cos raised to n minus 2x into 1 is cos raised to n minus 2x into dx plus minus, which is n minus 1 times of cos raised to nx into dx, because when bases are same, cos raised to n minus 2x into cos square x, bases are same, powers are added, n minus 2 plus 2 is just n. As we know that we have started with in. Okay, this is cos raised to n minus 1x into sin x plus n minus 1 times of, look at, when there is a cos raised to nx, we write in. When there is a cos raised to n minus 2 means I am writing this as in minus 2 minus n minus 1 times of, this will become just in. Okay, fine. Now you bring this minus n minus 1 times of in into left side. There is already one in. It will bring into left side. It will become plus times of n minus 1 into in, and the right side cos raised to n minus 1x into sin x plus n minus 1 times of in minus 2. Fine, here you can take in common, you will get to 1 plus n minus 1 is equal to, the right side is as it is, cos raised to n minus 1x into sin x plus n minus 1 times of in minus 2. Plus 1 minus 1 get cancelled. This is n into in. I am cross multiplying n here. You will get in is equal to cos raised to n minus 1x into sin x divided by cross multiply n plus n minus 1 divided by n times of in minus 2. This is the reduction formula for integration of cos raised to nx into dx. Hope you people have no doubt while deriving the reduction formula for cos raised to nx. It is, we have followed similar lines of actions of integration of cos raised to nx, integration of sin raised to nx into dx. Now further let's find out what is the integration of cos raised to nx dx between 0 to pi by 2. It's already here, just apply the limit. Okay, just you can write cos raised to n minus 1x into sin x divided by n plus n minus 1 by n into in minus 2 between the limits 0 to pi by 2. Substitute upper limit, as we know that cos pi by 2 is 0. Okay, substitute lower limit since it containing sin, again sin 0 is 0. The first term vanishes, first term becomes 0. So you will have only n minus 1 by n times of in minus 2. So therefore we have to start with in is equal to n minus 1 by n times of in minus 2. Like previous example, we need to find out in minus 2 as well as in minus 4, okay, by just substituting n by n minus 2 and n by n minus 4. You will get n minus 3 divided by n minus 2 into in minus 4. Substitute n by n minus 4, you will get n minus 5 divided by n minus 4 times of in minus 6. So we are substituting backwardly. Start with in. First write n minus 1 by n into in minus 2. What is in minus 2? Substitute n minus 3 by n minus 2. Okay. What is in minus 4? In minus 4 value is n minus 5 divided by n minus 4 times of in minus 6 by expressing continuously. So it will end with either odd number is we are writing I3, otherwise it will end with n minus 1 by n minus 3 by n minus 2 into n minus 5 by n minus 4, so on, end with even number. This is if n is odd, if n is even. Okay, now further look at carefully further. Now I will go for, okay, look at, now I will write in as it is. Okay, first you can write n minus 1 by n into n minus 3 by n minus 2 into n minus 5 by n minus 4, so on. I want to find out the value of I3. Substitute here, n is equal to 3 means I3 is 3 minus 1 divided by 3. 3 minus 1 is 2 divided by 3 into I3 minus 2 is I1. If n is odd. Similarly, n minus 1 by n into n minus 3 by n minus 2 into n minus 5 by n minus 4, so on, and with substitute n is equal to 2, 2 minus 1, 1 divided by 2 into I0, that is 1 by 2 times of I0 if n is even. Okay, now let us find out I0 and I1. Substitute n is equal to 1 here. What is I1? Integration runs from 0 to pi by 2. Cos power 1 into x into dx. Integration of cos x is sin x. Okay, between the limits 0 to pi by 2. So upper limit sin pi by 2 minus sin 0, sin pi by 2 is 1, sin 0 is 0, you will get 1. Similarly, find out I0, which is integral runs from 0 to pi by 2. Cos raised to 0 is just 1 into dx. Integration of 1 with respect to x is x between 0 to pi by 2. Substitute upper limit minus lower limit, you will get pi by 2. So finally, write in. What is in stands for? Integral runs from 0 to pi by 2. Cos power nx into dx is equal to n minus 1 by n into n minus 3 by n minus 2 into n minus 5 by n minus 4, so on. It is 2 by 3 into I1 value is 1. Okay, if n is odd. Okay, next n minus 1 by n, n minus 3 by n minus 2, n minus 5 by n minus 4, so on. 1 by 2 into I0 value is pi by 2 if n is even. So this is the value of integration of cos raised to nx into dx. Okay, so let us find out some 1 or 2 examples. Just look at by the application of this reduction formula. Let us find out what is the integration of 0 to pi by 2 cos raised to 4x into dx. So 4 is a even, you can use the formula. 4 minus 1, 3 by n is 4. 4 minus 3, 1 divided by 2. So this is the value. And lastly, it is end with pi by 2. The answer is again pi by 16. So let us calculate what is integration of cos raised to some 5x into dx between the limits 0 to pi by 2. take n is equal to 5 and 5 is a odd number. N is equal to 5. 5 minus 1, 4 by 5. 5 minus 3, look at 5 minus 3, which is 2 by 5 minus 2, 3. Okay, this is last value is n is equal to 5. So we are not going to consider this value. So either you can take last end with 1 or stop it here. So this is 4 2s are 8 divided by 15. Thank you so much for watching. Please subscribe our channel CGAT Maths Creative Guide Advanced Tutorial for mathematics. Please share to your friends, those who are very necessary about this concept. Thank you once again. Take care.